Welcome to another deep dive. Today we're going to be looking at something pretty cool, the quantum domino effect.
Domino effect.
Yeah, it's this idea that advancements in one area of quantum science can kick off breakthroughs in other areas.
Right. Yeah.
It's all like connected.
Yeah.
So to do this, we've got a few sources. We've got a Discover magazine article about a wild new quantum material.
Oh, wow.
We've got a piece from Physics World about entanglement networks.
Yeah.
And then, just to make sure we're all on the same page, a little bit of background from Wikipedia on quantum information and teleportation.
It's good.
Yeah, so get ready for some serious aha moments.
Yeah, I'm excited.
Okay, so let's unpack this domino effect. And I think the best place to start is with that Discover magazine article about this material that can actually bend the fabric of space.
Really?
It sounds like straight out of science fiction.
It does, huh?
Yeah. So how is that even possible?
Well, the key here is something called Berry curvature.
Berry curvature.
Yeah. Have you ever, when you go to the eye doctor
Oh, yeah.
and they're spinning those lenses around?
Yeah, one or two.
Which is better, one or two, yeah.
Exactly.
So that change in lens strength as the lens rotates,
Right.
that's kind of similar to how an electron's properties can actually change as it moves around.
Oh, okay.
And that change influences how it interacts with other electrons.
So it's like the electron is doing like a little dance or something,
Exactly.
depending on the moves if properties change.
Yeah, you got it. And what makes this new material that they're talking about in this article so special is it has both spin and orbital sourced Berry curvature.
Both.
Yeah. So you've got these two different kinds of Berry curvature happening at the same time.
Wow.
Which is something we really haven't seen before.
So what does that mean, like in practical terms?
Well, this could mean way more powerful electronics and also much more energy efficient.
Oh, wow.
Yeah, way more than anything we have today.
That's a game changer.
Yeah.
It is. But how does this new material, how does that connect to entanglement networks? Because, the Physics World article talks about how hard it is to transmit quantum information over long distances.
Yeah, you're right. That is a huge challenge.
Yeah.
It's really difficult to maintain that delicate, entangled connection between qubits over long distances.
Right.
And that's where quantum repeaters come in.
Quantum repeaters.
Yeah, it's think of them as relay stations for entanglement.
Okay.
So they're placed along the network to kind of refresh that entangled connection between qubits.
So I'm still a little fuzzy on how entanglement actually works.
Okay.
It sounds kind of magical.
It is kind of mind-boggling.
Yeah.
Essentially, you have these two particles that are linked
Okay.
in such a way that they share the same fate no matter how far apart they are.
Oh, wow.
So if you measure the state of one particle,
Right.
you instantly know the state of the other one.
So scientists are using this spooky action at a distance
Right.
to build these city-sized networks.
Exactly.
But isn't entanglement super fragile?
It is.
How can we build networks across such long distances if it's so fragile?
That's a great question, and that brings us to one of the coolest breakthroughs recently.
Huh?
Time bin encoding.
Time bin encoding.
Have you heard of this?
I don't think so.
Okay, so basically scientists have figured out how to encode the state of a qubit
Right.
into these time bins,
Time bins.
where a single photon exists in a superposition across 2 points in time.
What?
Yeah, it's wild.
So it's like a photon time traveler or something.
It kind of is, yeah.
Wow.
And these 2 points in time are separated by a tiny fraction of a second, 142 nanoseconds.
Okay.
But that's enough to make the entanglement much more robust.
So they're giving these entangled photons a time travel trick to make them tougher.
You could say that.
That's amazing.
Yeah, and this time bin encoding is going to be crucial for building those large-scale quantum networks.
So we're talking about networks that could revolutionize communication and computing.
Exactly.
It's amazing how this new material and then this encoding technique can work together to push the boundaries of what's even possible.
It is pretty remarkable, and it's all underpinned by the theoretical framework of quantum information.
Right.
Which is where our Wikipedia dive comes in.
Okay, so let's dive in.
Okay.
What are the key theoretical concepts that we need to grasp to understand how this domino effect is even working?
Okay, so first we need to understand qubits.
Qubits.
Yeah, the building blocks of quantum information.
Okay.
So unlike a classical bit, which
Right.
can be either a 0 or a 1,
Right.
a qubit can be in a superposition.
A superposition. Yeah.
Meaning it can be both 0 and 1 at the same time.
Whoa. So it's not just either or.
Nope.
It can be both.
Exactly. And this ability to be in multiple states at the same time is what gives quantum computers their huge power.
Okay. I think I'm starting to see how these pieces fit together.
Yeah.
So the new material could lead to better quantum computers.
Right.
And then those computers could use entanglement and time bin encoding
Right.
to create these powerful networks,
Exact.
the domino effect.
You got it.
Okay, so before we move on to like the final domino teleportation,
Right.
let's take a little detour back to the theory side.
Okay.
The Wikipedia article mentions something called von Neumann entropy.
Right.
What is that exactly?
So it's basically the quantum version of Shannon entropy,
Okay.
which is a way to measure the uncertainty or information in a system.
Okay.
Von Neumann entropy helps us quantify the uncertainty and information content in quantum systems.
So it's like a measuring stick for how much quantumness we can get out of a system.
Pretty much, yeah.
Okay.
And as we explore teleportation, you'll see how all these concepts, Berry curvature, entanglement, time bin encoding, and even von Neumann entropy, are all kind of intertwined in this quantum domino effect.
All right. I'm intrigued. Let's move on to teleportation.
Okay.
Okay. So teleportation, now we're not talking about like Star Trek beaming people up, right?
No, not quite.
Okay, good.
Yeah. Quantum teleportation is all about transferring the quantum state of a particle
Okay.
from one place to another, but without actually physically moving it.
So no teleporting ourselves to like a beach vacation just yet.
Not yet. But how does
Yeah.
this even work, right?
Right.
Okay, so imagine two people, Alice and Bob.
Okay, Alice and Bob classic.
Yeah, they share entangled particles.
Right.
And Alice wants to teleport the state of a third particle to Bob.
Okay.
So what she does is she performs this measurement on her entangled particle and the one she wants to teleport.
Okay.
Then she sends the results of that measurement over to Bob.
Oh, so we're not talking faster than light communication here.
No, no, no.
Okay.
That information about the measurement still travels at the speed of light.
Okay.
But here's where it gets really interesting.
Okay.
So Bob, when he gets those results, he uses that information to manipulate his entangled particle.
Uh-huh.
And because of the entanglement, his particle takes on the exact same state as Alice's original particle.
So it's like instead of sending a cake, you're sending the recipe for the cake.
Exactly.
Oh, wow.
Yeah, so it's like the information about the particle state that's being teleported,
Yep.
not the physical particle itself.
Wow, that is mind-boggling.
It is.
But it really works.
It does. Scientists have actually done this.
Really?
Yeah, they've teleported quantum states across the Danube River,
Wow.
and even from the ground to a satellite,
What?
over 1,400 kilometers away.
That's incredible.
It really is.
So the counterintuitive world of quantum mechanics can actually be used for like real-world stuff.
Yeah, for practical applications.
What are the implications of this?
Well, imagine a future where we can transmit quantum information between any 2 points on Earth instantly.
Instantly.
Yeah.
Wow.
We're talking about unhackable communication networks, incredibly powerful distributed quantum computers.
So what you're saying is like all these discoveries we've been talking about, this new material, the encoding techniques, and these teleportation experiments, they're all connected, right?
Exactly. It's all part of a bigger story.
And this quantum domino effect.
Yes, the quantum domino effect in action.
Yeah.
Advancements in one area, they trigger progress in other areas, and it just pushes the boundaries of what's possible.
Yeah. So just to walk through it one more time.
Yeah.
The new material could lead to more efficient quantum computers.
Right.
Those computers could then use entanglement and time-bin encoding
Mm-hmm.
to create these vast quantum networks.
Right.
And those networks could then use teleportation
Right.
to transmit quantum information instantly across the globe.
Exactly. It's like a chain reaction of innovation.
Yep. Each domino sets off the next one.
Exactly. And this domino effect has the potential to like completely revolutionize so many fields,
Like what?
not just quantum mechanics, but computing, communication sensing, maybe even how we understand reality itself.
Wow. Okay, so we've explored all four dominoes now, right?
We have.
What are like the bigger implications of that?
Practically speaking, developing more powerful quantum computers. That would be huge for things like medicine, material science, artificial intelligence.
So problems that are way too hard for even our best computers right now
Exactly.
could be solved in a fraction of the time.
Yeah, like imagine faster drug discovery, new materials with crazy properties, AI that's smarter than humans.
Wow.
The possibilities are endless, and the implications for communication are huge too.
Like how?
Well, think about it. A global quantum internet.
Okay.
Secure, unhackable communication, instant data transfer across huge distances.
Wow.
We could even connect quantum computers across continents like a quantum cloud.
That is mind-boggling.
It is, But with all this talk about these powerful computers and a quantum internet, it makes you wonder about the downsides, right?
Right. What about the ethical side of things?
Exactly. Like, could this be used for bad stuff?
Right, because any technology, especially one this powerful, could be used for good or bad.
Exactly. And that's why we need to have these open and honest conversations about the risks and benefits of this technology.
I
And we need to, like, figure out the ethical guidelines
Before it's too late.
right from the beginning.
Okay, so besides the ethics, are there
Yeah.
any other roadblocks that could, like, prevent us from reaching the full potential of this technology?
Yeah, definitely one of the biggest challenges is scalability.
Scalability.
Yeah, building and maintaining large-scale quantum computers and networks is really difficult and really expensive.
Right.
Those qubits are so sensitive
Yeah.
and they're prone to errors.
Right. It's not just about building bigger quantum computers then.
No, you need to figure out how to make them more stable and get rid of those errors.
So error correction.
Exactly, and fault tolerance. But scientists are making progress.
That's good.
New techniques for qubit design, error correction, fault tolerance, they're coming out all the time.
Okay, so it's an ongoing challenge,
It is.
but people are working on it.
They are.
Okay, so even with these challenges, it sounds like the future of quantum technology is pretty bright.
It is.
What are some areas where you see the most potential for breakthroughs?
Okay, well, for hardware, I think we're going to see better qubit designs,
Okay.
leading to more stable and scalable computers.
Okay.
For software, we need new quantum algorithms to unlock the true power of these machines.
Right.
And for quantum communication, the race is on to build those long-distance entanglement networks.
For the quantum internet.
Yeah, the backbone of the quantum internet.
It's a really exciting time to be following all this stuff.
It is.
It feels like we're on the edge of a huge technological revolution.
We are, and it's important to remember where it all started.
Yeah.
Like, what were those key insights and discoveries that made all of this possible?
Yeah, because it's easy to get caught up in all the hype.
Exactly. But the development of quantum mechanics back in the early 20th century, that was huge.
Right, it changed everything.
It completely changed how we understood the universe.
And it's crazy how those theoretical concepts back then have led to these amazing technological advances today.
Yeah, lasers, transistors, the internet itself, it all goes back to quantum mechanics.
And now quantum computing, communication sensing, we're taking it even further.
Yeah, we're entering a whole new era.
Okay, so we've talked about a lot today.
We did.
From Barry curvature to a quantum internet.
Yeah.
Why should our listener care about this?
The quantum domino effect, it shows us how connected scientific discovery really is.
Okay.
Progress in one area can have huge consequences in other areas that seem totally unrelated.
Right.
It's all about curiosity, collaboration, pushing the boundaries of what we know.
It shows that we're living in this incredible time of scientific and technological advancement.
And it has the potential to change our world in ways we can't even imagine yet.
Yeah, it really is amazing to think about how these dominoes are falling, like leading to all these breakthroughs that could change the world as we know it. So let's just do like a super quick recap to make sure we've got all the dots connected. And we started with this new material that can bend space.
Yeah, and that new material with its Barry curvature could be the key to making even more powerful and efficient quantum computers than we have now.
Right, and then we talked about entanglement, which is like that spooky action at a distance that connects particles even if they're super far apart. And scientists are using these clever techniques like time bin and coding to make that entanglement stronger so we can build those city-sized quantum networks we were talking about.
Exactly. And those networks could use quantum teleportation to let us communicate instantly across the globe, which is just mind-blowing when you think about it.
It is. It's like teleporting the state of a particle from one place to another without even moving it.
Yeah, it's all about the information, not the physical matter.
It's amazing how all of these discoveries that seem so different are actually each one building on the last one to create this like ripple effect of progress.
Yeah, it's a perfect example of how connected science really is.
So what's the one big takeaway you want our listeners to walk away with today?
Well, I think the quantum domino effect is more than just a bunch of cool discoveries. It's like a call to action.
Yeah.
You know, it reminds us that we need to be curious, to invest in basic research, and to work together across different fields because the future is being created right now. And it's up to all of us to make sure that these quantum advancements are used to help people and create a better world for everyone.
That's a really powerful message. It shows how important it is to stay informed and engaged with all of these advances, even if the science can seem a little bit intimidating sometimes.
Definitely. I totally agree. And there are so many great resources available online and in libraries like articles, videos, even online courses. Don't be afraid to jump in and explore this stuff. The quantum world is full of wonder and possibilities, and who knows, maybe you'll be the one to discover the next domino that sparks a whole new wave of breakthroughs.
That's a great point. Well, on that note, I think we've reached the end of our quantum domino effect deep dive. It's
Mhm.
been an amazing journey exploring the incredible world of quantum science and all the amazing things that are happening right now. Until next time, keep exploring, keep asking questions, and keep those dominoes falling.
Absolutely.